Good afternoon. Today we'll be discussing on how to solve questions on Olympiad physics. And today we have a question on Olympiad 2005, question 1, physics. Now the question says, figure 1.1, which is this, shows a network of resistors. This resistor and these two in parallel and these three in parallel, each of resistance R. So it means each of the resistor has a resistance R. Then I see the first is that the overall resistance measured between X and Y is 22 kilo ohms. What is the value of R? So now if each of the resistor has a resistance R, so now what is the resistance of each resistor? This is what this first equation is asking. And the second one, they say the power developed in resistor A due to the current that flows through it. Now let's assume there's a current flowing through it, I. So now the power is 1.8 microwatts. Calculate the power developed in the resistor B and C. So we have to calculate the power developed in this resistor B, which is very, very important, and this resistor C. That means you have to call this C. Since this is A, this is B, then this is C. So now this is what we are supposed to calculate today, and this is our solution. So first of all, we have to redraw our network. X A with a resistance R and a current of I flowing into it. Then that same current flows out. Then the current branch into I1, which goes to this resistor R, and that same current branch to I2 that goes into this resistor. Then both of them come together, I1 plus I2, which now go to this resistor, then to this resistor, then to this resistor, which we can call the current here to be I1, the current here to be I2, and the current here to be I3, so that they come out as I1 plus I2 plus I3, then to this point of Y. Here is Y. And we know from our knowledge of, and look, this question, the whole of this question in Olympiad carries 10 marks. So now, we know that a resistor can be connected in two ways. One is series and the second is parallel. So now when you look, you notice that this resistor R and R are all connected in parallel, because if you look, you notice that each of the resistor, each of there's a network of resistors, each of resistance R. So it means each of the resistance you see here has the resistor here has a resistance of what? R. So it means this resistor has a resistance of R, this has a resistance of R, this has a resistance of R, this resistor has a resistance of R continuously. So and we know that this resistor you are seeing here, all of them are connected in parallel. Why? Because they have the same potential difference, but of different current. So therefore, we can now resolve for this one by saying, since their potential difference is the same, comma, the current is different. Is different. Now this is the condition for what? For parallel connection. So since we know that the current I that flows in split into branch I1, I2, and I3, therefore I is now equal to I1 plus I2 plus I3, which you can call equation 1. Then, since from Ohm's law, V is equals to IR, then we can now make I the subject to have V over R. Now, assuming for more like for simplicity and to prevent confusion, let's name each of the resistance R1, R2, and R3. But I'll still go back actually. So now if we do that, then we will now have from here, then we will now have I is equals to I1 plus I2 plus I3, where I is equals to V over R. Therefore, V over R is the same thing as V over R1 plus V over R2 plus V over R3. So now, since voltage is the same, that means the potential difference is the same. Therefore, we can now write V over R is equals to V 1 over R1 plus 1 over R2 plus 1 over R3, where this can cancel, and R is the total resistance of R1, R2, and R3, and it is denoted by RT. Therefore, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And since we know that each of the resistor has the same resistance, each of resistance R, therefore, we can now see R1 is the same thing as R2, is the same thing as R3, is the same thing as R. Therefore, 1 over RT is the same thing as 1 over R plus 1 over R plus 1 over R. We can now have RT to be what? 3 over what? Over R. So that when we take the inverse, we now have RT to be what? R over 3. So it means for this branch, when you resolve it, we are going to have R over 3. And same thing for here. Since we are having 2, then we are going to have R over 2. Since we are having R over 3 here. Therefore, we are now going to have a new network to be R over 2, R over 3. And here is X, here is Y, and there is a current of I flowing in. Sorry, a current of just I flowing into it. So now if that is the case, we now know that all of these resistors are now in what? In series to each other. So we cannot take the total RT to be what? R plus R over 2 plus R over 3. So now recall from the question here, they say the overall resistance measured between X and Y is 22 kilo ohms. Therefore, RT is equal to 22 kilo ohms. Now we cannot equate 22 to be equal to R plus R over 2 plus R over 3. So now we cannot try as much as possible to simplify. We cannot say 22 is equals to R. Thus, just common multiple here is 6. 6 is going to here. Okay. 6 is 3 divided by 2 plus 2R 3R. Right? Okay. We can now continue here. 22 is equals to R plus 5R over 6. Right? Yes. Because the lowest common multiple is 6. 6 times this is 6R divided by 3 is 2. 6 times this is 6R divided by is 3. So we can now try as much as possible to simplify. So we now have 132 is equal to 6R plus 5R. So we can now rearrange. We now have 11R, the same thing as 132. So now when we divide both sides by we now have R is equals to 132 over 11, which is the same thing as R is equals to 12 kilo ohms. So it means now for us to get RT, we can now say, since we know that RT is the same thing as R plus plus R over 2 plus R over 3. So now RT will now be what? 12 kilo ohms plus 12 over 2 kilo ohms plus 12 over 3 kilo ohms. So now when we now 12 kilo ohms plus 12 over 2 is 6 kilo ohms plus, I guess 12 divided by 3 is 4 kilo ohms. Is 4 kilo ohms. So when we take the sum of them, then we can now have the total 22 kilo ohms. So it shows that each of the resistance R is 12 kilo ohms. So we are now done with this first one. So each resistance is 12 kilo ohms. So now the next question, the power developed in resistor A, this resistor A, due to current I is 1.8 kilo ohm. So question B, they say the power developing resistor A due to current I is 1.8. Calculate the power developing. So now, since they are in series, comma, the current is the same. So now, since the current is the same, we know that power is the same as what? I square R. So since we know that the power in this A is 1.8 microwatts, which is equivalent to 1.8 times 10 to the power of minus 3 watts. Now, we know that the resistance is 12 times 10 to the power of 3 ohms. Now, we can have, say, 1.8 times 10 to the power of minus 3 is equals to I squared times 12 times 10 to the power of what? 3. Such that we can divide both sides by 12 times 10 to the power of 3. We have I squared is equals to 1.8 times 10 to the power of minus 3 over 12 times 10 to the power of what? Of 3. So applying the law of indices, the current squared will now be equal to 1.8 over 12 times 10 to the power of minus 3 minus 3. So 1.8 divided by 12 is equal to 1.8 divided by 12 is equal to I squared is equal to 0.15 times 10 to the power of minus 6. So now when we take the square root of both sides, when we take the square root of both sides, then we are going to have a current of 3.87 times 10 to the power minus 4 ampere, or I is equal to 0.387 microampere. So now, then I'll say calculate the power developed in the resistor B and C. So to calculate the power developed in resistor B and C, so since we know the resistor B is the same thing as R over 2, then the power, since we know that the resistor is R over 2 for B, the power is now I squared over R. So this is now P is equal to I squared times R over 2. So you just have to say P is equal to I squared times 12 over 2. And since, close the bracket, and since I is equal to 0.387 microampere, we can now substitute and get the power for B. And for the power for C is the same thing, I squared R over 3. Then you substitute the resistance and the power, you have it. Thank you. And I hope you subscribe to my channel. And the whole of this question is 10 marks Olympiad Physics.